K19. K19, I did this one. It's also recorded in the 5th period video. Which basic trig function does cosecant go with? Sine, right? Okay, so we know what a sine function should look like. Some of you really need to focus on what's going on here because the test is coming. So there's your basic sine wave, right? You know that's 1 over sine. I drew a dotted line for the sine function. Why do I need that dotted line? What am I looking for first when I graph these? Why do I need these locations? What does a 0 on a sine wave turn into on a cosecant function? Asymptotes. Once you know your asymptotes, then you can do those fake parabola things in between. Just don't cross the asymptotes. Can you tell me where those asymptotes are? I mean, obviously 0 is one of them, but can you tell me where any of the other ones are? What was the thought over there? Pi, thank you very much. Any others? 2 pi, thank you. Negative pi, yeah, those are the ones on screen that we see right there. Can you give me the domain of that function? All reals except integer multiples of pi. Now, how do we need to say that? N pi, where n is an element of the integers, as I taught you that notation last week. Please make sure you use it. What's your range? Push all of those points onto the y-axis. How much of the y-axis would get covered? It would be a split range, wouldn't it? So you need one part for all those bottom parabola sections, and then one part for all the top sections. Negative infinity to what? Negative 1. Bracket or parenthesis? Bracket is correct. It does. It comes all the way and touches negative 1. That's why it's really kind of important to have the basic idea of what the sine function looks like. Okay, what's the other part? Thank you. Is this thing continuous or discontinuous? Definitely discontinuous. Yeah, you got to pick up your pencil a bunch. Where do you have points of discontinuity? Where do we have points of discontinuity? Yes. It goes along with that domain thing, right? The points of discontinuity are those integer multiples of pi, n pi, where n is an element of the integers. Now, what points of discontinuity are those? didn't have a jump. Okay? What's the last kind? The kind where they do this. But they don't ever touch, right? Starts with the letter R. Removable. So we have removable, jump, infinite. This is definitely infinite. Okay, so these would be infinite discontinuities at the n pi, where n is an element of the integers. I'm running out of screen room, so and I do want to see the graph for a few more questions here. Okay, so increasing, decreasing. This is going to get a little messy. So let's name one increasing interval. Okay, let's just name one of them. Because obviously this part is increasing, that's decreasing. That's decreasing, that's increasing. Okay, so there's a lot of increasing and decreasing, and they're separated. So, and yes, we could get some really fancy math language to describe all of them. I do understand that. But can you just give me one of them? One increasing interval. Pi over 2 to pi. Now, what are we going to put on either side of those? That's my question. Parentheses around the pi. Yeah, she's got herself covered there with that vertical asymptote. You ain't touching that vertical asymptote, right? What about the other side? So obviously she's right here, pi over 2. She's saying pi over 2 pi. Okay, so my question is, what's going on there at the bottom? If you're on this roller coaster right there at the bottom, are you increasing or decreasing? Neither. Right at the bottom, you're doing nothing. Neither of those. So, I see. I'm like, why do I have a really bad feeling at the moment? Okay. And on the left side of pi over 2, since we decided at the bottom you're not increasing or decreasing, what should I put? Parenthesis, thank you very much. And oh, I forgot to lock it in place. Yep, it's got to be a parenthesis. How about a decreasing one? Nice. 0 to pi over 2. Okay, symmetry of the graph. Is this reflection symmetric across the y-axis? Can you take this thing, right with the y-axis, hold it together, and it looks exactly the same? No. Because if it did, then this section would have a duplicate right there, and it don't. Alright, so it's not even. Can you rotate it around the origin 180 degrees to make it look exactly the same? Or it's not functional. Hey, by the way, sine, you know the one that he goes with? Is it even on you? Got it, one right here there. That's on. It's what? It's reciprocal. Should supposed to be the same. Okay, odd. They go together. Yes, connections. Good thing. Okay, boundedness. Boundedness. Is it bounded above, bounded below? If you say the word bounded, you think it's both bounded above and below, or not bounded at all. Which do you think? Unbounded? Okay. Now, for those of you who are questioning that, bounded above means you think I can draw a line above the graph that it never will go over. Most of you would probably agree that's not true. Bounded below would mean I could do the same thing on the bottom. I could draw a line that it would never go below. And that is also not true. Okay, so not bounded is correct. Okay. All right. Extrema. Can you name one relative minimum?
Can you name one relative minimum? Oops, sorry. Sorry, I was sliding up on that screen. Relative min. Okay, 1. That is a relative minimum. Now, what impresses me about what you said was, you named a y value. Relative mins and maxes are all y values. So it is 1 and it occurs at, so if you are specifically talking about that one right there, what x value is it occurring at? Okay. How about a relative max? Not the same two people. No. I appreciate the thought. I really do. So relative max. Do we have any relative maxes in the house? -1 is the y value. Sure. Okay. So which one do you want to pick? You pick the one on the left or the one on the right? The one on the right. Okay, we'll do that. Okay, so -1 is the y value. Okay. So we're focusing on that one. We got -1 at x equals, what's that x value? Halfway between pi and 2 pi. You could even think about it on a circle. Come on, folks. I don't know. It's halfway between pi. 3/2. Why did I write 3 pi? 3 pi over 2, yes. Okay, last thing they want to know about is end behavior. End behavior requires we write something that you all hate, and it doesn't really matter. I'm going to do it anyway. Remember this? The limit as x approaches infinity. Okay, folks, we're going that way on the graph, a long way. What's the limit? Is the limit an x value or a y value? We know the x value is going to infinity, so I'll give you that clue. It's a y value, right? Limits are y values, right? And we want to know if it's getting closer and closer and closer to one particular number. What do you think as you go that way for a long way? Is it getting close to a particular number? Well, you got this one right here, and over here you got another one, and over here you got another one, and over here you got another one, over here you got another one, and you got another one, and another one. No. So what does that mean? Come on, mean girls. The limit does not exist. Thank you very much. Right? The limit does not exist. Okay, folks. What about the limit as you go to negative infinity? So what happens on the other side? Hopefully you realize that it's the exact same thing, right? The limit does not exist on that side either. Okay, we did know the reference of the whole Mean Girls thing, right? Okay, alright. Just making sure. Nobody thought I was like calling them out.
I'm surprised you knew that.
Surprised I knew that. What is that? Okay. Just the reference to a movie.
I agree with that.
We should? Right after nap time. I think it starts at 2:35. Okay, so, next. What's any 4 or 5 questions that we need to go over? You had last week to do 4, 5, 4, 7, 4, 8 in the Ferris wheel worksheet with the data on it. I'll dig one up and post it for you. Which one? 15? Okay, question 15. Secant goes with what? Cosine? Alright, so this is really like looking at 1 over cosine 2x. Now, let's see here. What does cosine 2x look like? Cosine 2x. Anybody know how to put that in fireproof form? Cosine 2x. Come on, 2x over 1. What are we doing to the top and the bottom? Hopefully you multiply it by 1/2, and so you would realize what's going on. Horizontal shrink or stretch? Horizontal shrink or stretch? Come on, folks. We see the a value is a 1/2. That's a shrink. So, when we graph this thing, we should realize what's the end of the cycle? Only 1 pi, right? Because we shrunk this thing down. So what's so special about those x-intercepts I'm circling? What's so special about those? X-intercepts on the original, and I probably should have done that with a dotted line. My apologies. Let's see if I can quickly erase that and do that with a dotted wave without screwing this up royally. Okay, that's really, really rough. Alright, so what goes on with those x-intercepts? Come on, show me something here. Vertical asymptotes. Okay, so pi over 2 is in the middle. Can you tell me what those vertical asymptotes are? Any of them. Can you name any of those vertical asymptotes? Pi over 4, excellent choice. And what's halfway between pi over 2 and pi? Halfway between pi over 2 and pi. 3 pi over 4. Basically, think about taking the normal ones and then cutting them in half. Okay, this one over here obviously is negative pi over 4. And negative 3 pi over 4. Now that you have the vertical asymptotes, you can do the little fake parabola thingies. We can go through and answer all these questions. Since we did a horizontal shrink, will the range change? Listen to my question. Will the range change since I did a horizontal shrink? Or is the range still negative infinity to negative 1 bracket union 1 to infinity? The horizontal shrink didn't do anything to that range. It changed my domain, right? All reals except what? Got to be careful here. So we would have, I will let you get away with integer or odd integer multiples of pi over 4. Because if I try to write out the technical math definition of that one, you might get lost. Can you tell me whether this is an even function or an odd function, or neither. It is an even function. You can fold that right on the y-axis. It'll look the same on both sides. Okay, I'm not going to go through all the details just like we did on the other one. We've got the most important details right there. You're going to find very similar things going on with all the other things. Okay, another type of question. Is there any other types of questions for 4-5? I believe in the video, if you, I did, let's see. What did I do from 4-5? I did 37, and I believe I did 49. Nope, that's 9 must be on the other. No, I did 37. Is there anything else on section 4-5? Okay, switch over to 4-7. I know I did 49 in the other video. What from 4-7 do you want help with? Or 7 was good. Kind of making me a little uneasy. Got a test coming up and nobody's asking me any questions for that section. I'm like, okay, yes. 15. Too fast, too furious. 15. Why do I not have 15 even written down? Okay, that's strange. Alright, fire away. What's 15? -1 parenthesis 12.5. Negative 12.5. I would need a calculator for this. Did they give me more specific information? Like, did they indicate whether the answer needs to be in radians or degrees? It does say degrees? Okay, so you would need to make sure you're in degree mode to answer this question. And you're literally going to type that on a calculator. That's it. I mean, there's nothing more about that question that I can expound on. Now, -12.5. Okay. Well, I should say this. I can give you a little bit more detail. Or at least quiz you on another idea. What's the range of the inverse tangent function? What's the range of the inverse tangent function? And since they want to know degree, we'll speak degree. What's the range of the inverse tangent? Well, okay, we did inverse cosine. Inverse cosine looks like my father's really old hairstyle. I'm not kidding. The comb over. Yeah, I can't do it. I'm never going to do that. Okay, so this is the range of the inverse cosine, so what's that one? Come on, we waved our hands in the air just like we cared. 0 to what? Oh my goodness, folks, this is not going to go well. 0 to pi. How about the range of the inverse sine function? Look in your notes, man. Look in your notes. Does it include the endpoints or not? Yes, it does. Oops, sorry. I said yes, and then I ignored what I said. Range of the inverse tangent. Same thing with one exception. Does not include the endpoints. Now, yes, folks, We typically write things in radian mode. They have set degree mode. So, if I change this to degree, it would be negative 90 to 90. Negative 12 and a half. Is that a slope, an x value, or a y value? Come on, negative 12.5. Is that an x value, a y value, or a slope? This should be easy. That's a slope. I mean, the lowest y value or x value you can find on the circle is negative 1, so it wouldn't even make sense to be one of those, right? It has to be a slope. So if the slope is negative 12.5, without using a calculator, can you give me an approximate idea as to what that calculator is going to tell you? Where is negative 12 and a half? And it has to be in the blue section. Quadrant 4. And guess what? Gotta be pretty doggone steep. Give me an idea. What's it going to spit out? Throw a number out. It really doesn't matter as long as you got the right idea. What do you think? Okay, it has to be between negative 90 and 90. 85 degrees, that's right about there. Is that what you really meant? Negative 85. I'd take that. That's a good estimate. Because you know it's got to be a steep slope. I don't know, maybe it's negative 87. I don't know. Maybe it's negative 89.2. It's got to be pretty close though. What happens? What you get when you inverted it? There you go, negative 85.4 something. But looking at the idea of what slope is, what kind of angle measurement does the inverse tangent function spit out? Those are things, those are details you need to know. Okay, what else? Homework-wise. 4-7. Anything else 4-7? So that's all good. I sure can. Question 47. Tangent inverse x. That's equal to theta, folks. How do I know that? Because tangent inverse always gives you an angle. Just like sine inverse and cosine inverse. Upon further inspection, you'll see that that really says tangent inverse of x over 1. Which side of the triangle should I be labeling x? And which side should I be labeling 1? That side is what? X? Which one's 1? Yeah, nice job. I like it. So, what does that mean about the hypotenuse? What? No, they do not. What's my hypotenuse? Come on, use your sides. Just tell me out loud. It can't be radical 2 because I don't know what x is. Radical 1 plus x squared. Would it be okay if I said radical x squared plus 1? Yeah, that's another equivalent thing to say. So there would be nothing wrong if you said this. Okay? For those of you who don't know, 1 squared is 1. Just, I know. I just thought I would just, I didn't want to be like, where did that come from? Okay. Alright. So, what are they asking me for? Sine? What's the sine? Opposite over hypotenuse. The inside part gave me enough information to build the triangle. After that, I need to pay attention to the trig function on the outside to know which one they're asking me for. Okay, any other questions on 4.7? Yes. Sure. Arc sine. That's the same thing as sine inverse. Was that a question? Did I cover that in the notes? I hope I did. Arc sine and sine inverse are exactly the same. So, which side should I label x and which one should I label 1? Boy, if I only had like a shadow on the screen, it would point to the side that was an x and the side that was a 1. That's like in the middle. Where's it going? Where's the x? Oh, there it goes. Oh, yeah, there we go for our x. And Mr. Rupert, you threw down the hypotenuse for 1. Thank you very much. The two of you, great teamwork. What does that make for the leg at the bottom? I'll give you a hint. It starts with the square root. 1 minus x squared. That's true. I know. And question 49 asks me for the tangent. Tangent would be opposite over, yeah, the adjacent side. Once you build the triangle, it really won't be that bad. Okay, any more 4.7 questions before we move on? Now's your time to ask a 4.7 question. I mean, I'm taking questions all day tomorrow too, so, but